Hey guys, I just wanted to show you the progress on the Amiga emulator implementation. So just to be clear, this is a port from SAE, scripted Amiga emulator. So I ported from that to Object Pascal. So it's a sort of one-to-one port, each part. Most of that port was done by AI, so I can't really, sit there and say that, hey, look what I made, because it's not true. It's an AI port so far. I've gone into the CPU unit and made some changes there. There are some language features that Object Pascal is really good at that JavaScript doesn't have. So yeah, getting a little speed bump by optimizing it. And I'm going to optimize all the units once they're done. So today's edition is sound. There's still some timing issues, especially when the track disk is running at the same time, uh, because there's no threading in JavaScript. So if it has to do something, then something else has to wait. So when you have demos that loads from the disks while it's doing something else, that can, create issues with the timing. So I'm trying a sort of circular updating mechanism, see if that helps. But um, yeah, nine fingers and those kind of demos are struggling a little bit. So, but I'll figure it out. I'll get it working. Um, so the only thing missing from this now is, joystick support. And then we're roughly at an Amiga 500, baseline. I haven't added CAM support yet, so I'll be looking at that moving forward. And then the ECS, enhanced chipset stuff, and then Amiga 1200, which is the one that most people use anyway. So I might as well just go for an 040 instruction set support and try to add, the AMMX stuff, and RTG, of course. So, but right now I just, I want to get the graphics as smooth as possible. I had a lot of graphical glitches yesterday, and I'm glad most of them are gone. Again, it has to do with timing. Whenever, the track disk goes off, like it does on the Nine Fingers demo, it starts loading and, it's basically loading video, uh, 2-bit video or something like that, decompressing it at the same time as the demo is, presenting the frames. So graphics is really easy to screw up if the timing is off. So it's just getting it just right. That's the key. But let's have a look. We can try with Batman Rises. I had real issues with this one yesterday. Uh, I had screwed up the sixth bit plane, BPL06, was set wrong. So it was showing, a lot of garbage. So yeah. Yeah, it's more. There was a shitload of garbage on that yesterday. Yeah. This has to do with the VBL. I need to sync with the VBL. I didn't bother doing that. it's working so well. You kind of hear the audio has a slight click in it. That's the timing, the round robin update the chipsets thing. Yeah, I just reset it. Let's see, eject, reset, and pause. Okay. Yeah, as you can see, it does work. It needs a little bit of tweaking here and there, right? Some timing issues. Uh, Honestly, I'm surprised that it works as well as it does. I mean, it's JavaScript at the end of the day. Uh, so once we get this over to WebAssembly, I think the timing issues will resolve themselves. Um, I might split them up so that you have audio is pulled using a web worker or something like that. But the cool part is that this can run headless. So you don't have to, run it as a visual thing. You can run it like a service in the background with no user interface or anything. And then we can have a client that sort of connects to it and basically streams audio and video. And that also means that it can run at much greater speeds. It won't be limited by, the browser's frame rates. So the browser has a hard frame rate of 60 FPS, and it also tries to use as little CPU power as possible. So running it under Node.js, for example, is going to eliminate some of that. And that's a cool thing when it comes to the desktop, because you can actually run the emulator server side. And if two people are connected to the same server, you can actually play two-player games, which were never designed to be played remotely. So that's an Easter egg. Yeah. Okay. Cheers.